I want to do a couple examples for solving absolute value inequalities that are or inequalities. So anytime you have a greater than or greater than or equal to, when you graph, the solutions will be pointed away from each other with no intersection. You don't decide whether you have an and problem or an or problem until the absolute value is isolated. You could write this as two separate inequalities joined by or, and the special case is when absolute value of something is greater than a negative number. This is always true. So the solution is that you could choose any x, and this would still be true. So we say that's all real numbers. Here's example 1. I need to isolate the part that has absolute value. That's my first step. So I'll move the numbers that are beside this. I'll subtract 9 from each side of the inequality. That leaves 2 absolute value 3x minus 4 is greater than negative 4. And then these are multiplied together. So I divide to isolate, which leaves me absolute value 3x minus 4 greater than negative 2. Once it's isolated, I can determine by what inequality symbol I have, whether it's an and problem or an or problem. Since this is greater than, once it's isolated, I'll have an or problem. And those graph on the outsides of a number line pointing away from each other. Like this. That's what I should expect to see. To continue solving, I take the absolute value brackets off and put everything inside in parentheses instead. So I can make two groups with 3x minus 4 greater than negative 2. And one will be the positive direction and one will be the negative direction. For this positive group, if I distribute positive 1 into the parentheses, I don't change anything. I could just take the parentheses off. I'll have 3x minus 4 greater than negative 2. And to solve for x, I add 4. Now I have 3x is greater than 2. And I divide by 3. So this solution is x is greater than 2/3. My second problem is the negative direction. When I distribute negative 1 into the parentheses, I change the signs of both terms. So the problem I'll solve is negative 3x plus 4 is greater than negative 2. I'll subtract 4. Now I have negative 3x is greater than negative 6. And I divide by negative 3. Anytime you divide by a negative number with an inequality symbol, this flips. So I will change my inequality symbol to a less than. And the solution is x is less than 2. when I graph my solutions, I should expect to see that these graph away from each other. And what I have here is 2/3 and 2. I have open circles because my inequality symbols do not have an equals with them. They're only greater and less. I have everything greater than 2/3 and everything less than 2. Okay. This is the whole number line. Since when this was isolated and I had a greater than and I decided it was or, this isolated problem is greater than negative absolute value greater than -2. This is always true. Definition of absolute value says that everything could be equal to a positive number or greater than or less than a positive number. But here I have greater than a negative, and that's there. I could choose any x for that. So since I could choose any x here, and I can see that with the solutions I graphed, which is all x's, these are correct technically, but my best answer for this is that I have all real numbers as solutions. Here's another OR problem right beside. Again, I need to isolate the part that is absolute value. I can't distribute into here. I can't take anything out of it. I need this to be isolated. So only absolute value 2x plus 2, and then an inequality symbol, and then a number on this side. So I need to move the 4 and the -10. If it's easier to think of for solving strategies, we could take the absolute value expression out and replace it with a. You can also rearrange the left side of this if you want to. Try this. These are added together. I have 4 plus -10. This basically 4 minus 10. I'm calling this a for absolute value. It's very common that students will try to combine these. So let's just rearrange this way. These are still added together. These are equivalent, but for some reason, we're less likely to solve this incorrectly. So I'm just gonna call this expression A until I get it isolated. My first step for isolating would be to move the 4. So I'll subtract. That leaves me -10 times the absolute value expression is less than -80. And then I divide each side by -10, the coefficient of A. When I divide by a negative number, because these are negative, I flip my symbol backwards. And I have A is greater than 8. This one isn't any kind of a special problem. I have a positive number here. I have an isolated absolute value expression. I can replace the 2x plus 2 now. Yeah, 2x plus 2. This is greater than 8. This is something that I can solve. It will be an OR problem. And I'll just split this into two groups. I'll put 2x plus 2 in parentheses greater than 8. And again, 2x plus 2 greater than 8. I need to add the directions back on, so I'll have a positive group and a negative group. And when I multiply this expression times 1, I still have 2x plus 2, and it's still greater than 8. To solve, I would subtract 2, which gives me 2x is greater than 6. And then I would divide by 2, and I would have x is greater than 3. I didn't change the symbol. I didn't flip my symbol when I divided by 2. It's only if you multiply or divide by a negative number. So I'll put 3 here with an open circle because there's no equal sign. And my solutions, some of my solutions are the numbers that are bigger than 3. For this negative direction group, I distribute the negative in, which changes the signs of both terms. So I have negative 2x minus 2 greater than 8. To solve for x, I would add 2. So negative 2x is greater than 10. And then I divide by negative 2. When I divide by the negative, I flip my symbol backwards. So my solution is x less than negative 5. And I can graph that this way. And this is the way I expect an OR solution to look on a graph. This is typical.